So in this question, once again, I'm going to be looking for the angle x in a given triangle below to the nearest degree. So you can see here we're given the length of two sides, the side BA. So the reason it's called BA is because we have, as you can see, the corner B, or the vertex B, and the vertex A. So the side BA is just the line which connects these two dots. And then the same thing for BC here. So we're given these two lengths of 8.4 and 6.6. And what we're going to be looking for is this unknown angle here, x in the bottom right corner. And so we're getting loads of practice basically with these trig identities. In this one, I'm actually going to dive into SOHCAHTOA a little bit more. So just to explain SOHCAHTOA, so it's a made up word basically we use for the trig identities. So it starts out with SO, which we're going to explain in a second here, and then it goes ka, and then toa at the end is of course TOA. And so what this means is that if we take sine as an example, the sine of the unknown angle is going to be the opposite over the hypotenuse. It's obviously very important that it's always a right angle triangle, so we can see that the side, or the vertex B here has a right angle down in that bottom left corner, so that's always going to be a crucial kind of aspect of this. And then the ka stands for cos, the cos of the angle x being the adjacent of the hypotenuse, so a over h. And then finally for tan, the tan of x is going to be the opposite over the adjacent. And so those are going to be our three trig identities we use for right angle triangles, and you will have to learn them off because unfortunately they don't tell you which one to use in a specific situation, but with a bit of practice it's usually not too hard to spot. And so now our job is going to be to figure out which sides we're given in the question. So we can see here I always like to start with the side opposite the angle, because you can just draw an arrow straight across, and you can see that the side opposite the angle x is going to be this side BA, which is 8.4, so that is going to be our opposite, and we know that length. And then the next side I always like to go to is the hypotenuse, which is the longest side. And so the longest side in this case, it's always going to be the one opposite the right angle, which is also good to know, but the longest side we actually don't know. So the longest side is going to be just a question mark. We don't know the length of that, but we do know the length of the last remaining side, which is the adjacent, the side B beside the angle, and that is going to be 6.6. So in this case we have the opposite, which is this 8.4, so that's O, and we have the adjacent, which is the bottom side here, and that is going to be A. And so of course, if we look at our trig identities, we have O and A, so we need to use tan. So we're going to be finding the tan of x, and that is going to be what we use here. So now we just need to plug our numbers in. So we've labelled the opposite over here, that's 8.4. So the tan of x is going to be 8.4 over the adjacent, which we know is 6.6. And so the problem we have now is that we basically don't actually know which order to do things in, because we have, I suppose, this tan of x. We're not used to working with unknowns where you have the tan of an unknown. And so we basically need to get rid of the tan, because then it's going to be nice and obvious what we need to do. And so to get rid of the tan, what we need to do is basically invert it. So we leave the x on the left hand side, and what we do is just bring the tan across, and when you are bringing a function across, rather than dividing by a function, you can't really divide by a function, you end up getting the inverse on the other side. So to bring a function across, you get the inverse of the other side of the equation, and that is going to be the tan inverse of 8.4 over 6.6 in this case. So hopefully that makes sense. We're just bringing the tan across to the right hand side, which means inverting it. And now we can simply get the value of our angle as a number in degrees. And so the value of this angle, when we plug the tan inverse of 8.4 over 6.6 in our calculator, is going to be 51.84 degrees. So that is going to be the final answer for this question, and that is going to be it for this video.